What does insulin do on a cellular level? And what about glucagon? So some of you might just know that, like you have been studying this since you were 4, and others of you are kind of like, oh, something about blood sugar, I bet. So let's again, we really need to cover, everyone needs to be solid on blood sugar balance and what's affecting it, because this comes into play when we get to our clinical information in a little bit. So why do we even care about blood sugar regulation? What's the big deal with blood sugar being, in the appropriate range? The big thing is that we need to have fuel when we need it. And many of the parts of the body run on glucose. So when we've just eaten, let's say, many of us probably just had dinner, and if you've just eaten, the availability of blood glucose is not a problem because you're breaking down your meal, you have a lot of glucose coming into your bloodstream, everything's good there. You have all you need, you have an abundance, if you will. But in between meals, for example, let's say you don't eat anything else for the rest of the evening, you go to sleep, you wake up in the morning, it will have been, who knows, 10, 12-ish hours since you last ate. At that point, at some point during that time, you're going to run out of readily available glucose coming in from that last meal. And in that interim period, you need to have enough fuel to run your body, right? So balancing blood sugar is all about sustaining the body in between meals, in between the time that food is coming in. Now, one solution to this would just be to rig up some kind of system where we had blood sugar just running around willy-nilly, wild, as much as we wanted. The problem with this, among other things, is that blood glucose has what we call high osmotic pressure, meaning it draws water towards it. So when blood sugar is really high chronically, you wind up essentially dehydrating your cells. The other big problem with having extremely high levels of blood glucose all the time is that glucose is very inflammatory to the tissues, especially in the blood system, the vascular system. So we can't just set up some kind of system physiologically where blood sugar is always high and nobody has to worry about it. Instead, we have to regulate carefully and make sure that glucose is available, but not too high. The levels are not too high. Okay. So what we do is, when we've just eaten, when we have an abundance of nutrients, including glucose, coming in, we store things. We store the glucose so that we can get it later when we don't have any coming in via the digestive system. And there are 2 ways that we store energy. One is glycogen. So basically we take individual glucose units and we mush them together in long chains, and that's called glycogen. Okay? And the liver and the muscles can do that. Okay? And you can store enough like this to last you about 4 to 5, most of us about 4 to 5 hours. Officially, technically, you could potentially go up to 10, 15 hours like that. But for the most part, you're looking at a pretty short-term solution. So we do have some as glycogen, and I like to think about glycogen as the under-the-bed storage box. For example, if you aren't using something very much, you can put it under the bed and it's out of your closet, but you can still get it pretty closely if you need it, right? The other way we store things is as fat, right? And that's pretty common knowledge. And fat is a very efficient way to store energy. We can store a lot of energy as fat, but it's a little bit harder to access because fat metabolism, meaning if you want that energy back, it takes more time to break down the adipose tissue and get the glucose out of it. So I like to think about storing glucose in fats as kind of like putting something in long-term storage where you have to drive across town to go get it. So again, it's there if you need it, but it's not super convenient to go get it. All right. So that's what we do when we've recently eaten. Now, one other quick thing. So the reason that we need glucose even when we haven't eaten is primarily because of the brain. So the brain likes to run on glucose and it prefers to run on glucose. The reason is because glucose is a really clean burning fuel. doesn't have a lot of byproducts, and the brain is a really sensitive tissue. So it can't, if you will, detoxify some of the other macronutrient fuels as well as it can glucose. There are certain other tissues, for example, the retina in your eye, gonads, the ovaries and the testes, and red blood cells also prefer to run on glucose. So we have to have a system set up so that those tissues can get glucose when you haven't eaten recently, but everyone else, all the other tissues out there, can run on something else. They don't hog up all the glucose if it's not freely available. And that is basically what insulin and glucagon do, is they set it up so that when you haven't recently eaten, that the important tissues, the brain, the retina, the gonads, can run on glucose and that everyone else can run on something else. We'll have a very brief discussion of that right here. So when we have just eaten and there's food coming in through the hepatic portal vein into the liver and then to the rest of the body, that's what we call the absorptive phase, because you're absorbing nutrients into your body. You have a ready supply of all kinds of different things. And during this phase, insulin levels are high. So insulin dominates, and in the presence of insulin, virtually all cells in the body can absorb glucose. So it's almost like like it unlocks the door so that they can absorb glucose into the cells. And again, what we do during this phase is we increase our storage. So insulin, part of what it does is it signals the body to make more fat, to make more glycogen, to increase protein synthesis. It's all about abundance and saving and storing things, which is a good thing because we want the body to be storing up anything that's extra during this time. Okay? And for those of you who are a little bit more biochemically minded, essentially what happens is that in the presence of insulin, you insert transporters that allow the cell to absorb glucose. If that's too much for you, then just ignore it. Don't even worry about it. Okay, so that's the absorptive phase. Now, the post-absorptive phase is when you haven't recently eaten. So it's getting to be, 2 a.m. or whatever, and assuming you didn't have a midnight snack, you don't have any ready source of fuel coming in through the digestive system. And at this point, the brain still needs to run, presumably. So at this point, what you need to do is start breaking down the glucose that you have already stored and letting that out into the bloodstream. And at the same time, you need to make sure that all of those other cells that don't have to run on glucose are not using it up. So at this point, when you don't have any nutrients coming in through the digestive tract, insulin in healthy people is suppressed, and glucagon, which is another pancreatic hormone, rises. And glucagon tells the body basically to break down your stored nutrients. So it's telling the liver to break down glycogen. It's telling the liver to actually make new glucose, which it can do. And it's also encouraging the breakdown of fat. Now, the reason that the other cells in the body, for example, the digestive system, the kidneys, the hearts, all of those, are not using glucose is because there's no insulin. If you don't have any insulin there, then they can't absorb the glucose. So it's essentially being saved for the tissues that need it. The tissues that need it, remember the brain, the gonads, the red blood cells, the retina, they are what they call not insulin sensitive, meaning they can absorb glucose whether there's insulin present or not. So there is a special type of mechanism that they have. Okay, so this is all very interesting, right? So you have a basic idea of how blood sugar works. There's a couple of interesting points that I want to make. One of them is not related to nutrition, but I think as I believe most of you are practitioners or soon-to-be practitioners, I do want to explain this, is the effect of insulin and exercise. Because, again, a lot of people don't understand this, but it's a really fascinating thing. So remember, we talked about most of these tissues, if there's no insulin present, they can't absorb glucose. There is one exception, and that is skeletal muscle. When it is exercising, so when it's actively working, skeletal muscle can absorb glucose even if there is no insulin. The reason that that is extremely important for you as a practitioner is because if somebody needs to lower their blood sugar and they're either insulin insensitive, meaning they have insulin resistance, or for whatever reason, one of the quickest ways that you can get your blood sugar down is to actually exercise using some of the larger muscles, for example, the quadriceps. So, doing squats at the wall, for example, will actually suck up a lot of glucose out of the bloodstream without involving insulin at all. And the reason for that is because the skeletal muscles, when they're exercising, the body doesn't want them to run out of fuel, and there's only so much they can do in terms of the glycogen that they have stored. All right, well, that was a non-clinical nutrition tidbit, but I think it helps highlight the importance of exercise for people who are having problems with blood sugar balance. So we'll go into a little more detail about this again later. But while we're here, I do want you to think about this in terms of when you eat. So if you, in the absorptive phase, the goal is storage, right? The goal is put everything away into fat cells, essentially. And in the post-absorptive phase, that is when the hormonal profile is right for breaking down fat and so on and so forth. Well, if you think about this in terms of people who are trying to lose weight, one thing to me that this highlights is the importance of actually going into the post-absorptive phase. Because some of you, if you're in practice, I think you've probably seen this before, you'll have some people who essentially eat so frequently that they are constantly in absorptive phase, right? So they're never fully making it into post-absorptive phase unless they're sleeping when they're asleep. But if you're trying to actually go into that fat breakdown mode, you need to have time where you're in post-absorptive phase. Now, some people, of course, this is going to take a very varied amount of time depending on your individual metabolism, genetics, and so forth. But it is something to consider that super frequent snacking and meals, while it might suit some people, especially if they tend towards what they call hypoglycemic state, for other people, especially people who are trying to lose weight, you need to let them get into this post-absorptive phase in order for that to be effective, because otherwise, if you have nutrients coming in through the digestive system into the blood vessels right there, the hormonal profile is literally such that you're not going to be able to break down fat during that period of time.